Okay, section 9.7, we're going to talk about dilations, which is the last transformation that we'll talk about. A dilation is a transformation in which the original figure and its image are similar. Okay, so if we have a dilation, we always dilate from some center. It's very similar to a rotation, and the center is going to generally be at C. So if we have a dilation with a center C and scale factor K, it maps every point P, which is just representative of the kind of the beginning point where you start, to a figure to point P prime, which is where you end up. Okay, so for instance, if I wanted to take triangle DEF here, and I wanted to dilate it, by a scale factor. We always represent scale factor by K, right? If we think back to geometry A, we always represent scale factor by K. So let's just kind of do an example here real quick. If I take DEF and I want to kind of dilate it and make it bigger, dilations can be enlargements or reductions. But if I want to make it bigger, then all I do is I connect the line here, C and D, in the straight line, and kind of extend that line further out away from the original figure, which is where I want to, which is what I'm trying to do, is just kind of blow this whole triangle up. Okay, so maybe somewhere out here, I don't know, we have D prime, depending on how big we want the triangle to be. And then we do the same thing for E. We draw a straight line from C, the center, through E. Very straight line. And we find out where E has to be. Now, this is kind of more of where the judgment kind of comes in. We've got to be careful if you don't have a ruler. E prime's probably right about there. And then we do the same thing for F. And now F is going to run into my letters here. I apologize. But we do the same thing, and then we connect the dots. And that's our new triangle, D, E prime, F prime. Okay, and that's it. And so if I can assign lengths to these, and you can't see the F, to F prime. If I assign lengths, it might kind of give you a more concrete idea of what K is. Okay, so let's say that the distance from C to D is 2 units. Actually, let's use a different color. Let's use maybe. Well, I guess that'd be okay. Let's use is 2 units. Okay, and let's say the distance from C to D prime, the whole thing here, from C out to D prime. This is very, very important. The whole thing from C to D prime is 10 units. Okay, the distance from C to D prime, not D to D prime, but the whole thing, okay, is 10 units. Then my scale factor K equals CD prime, that short segment, divided by CD prime, the whole thing, divided by the short segment, CD. Okay, so for this example, K would be 10 divided by 2, which is 5. Okay, so my scale factor is 5. Alright, and that's basically all there is for dilations. The shapes will be different, they won't always be triangles, but that's basically all we're doing for dilations. Now, a dilation can be an enlargement or a reduction, and if a dilation is an enlargement, then K must be greater than 1. Okay, so like in our example up there, K was 5, so we were blowing the triangle up. In a reduction, K must be between 0 and 1. K can't be less than 0, but K can be between 0 and 1. K can be between 0 and 1. Real quick, let's talk about, in geometry A, you learned that the coordinate rules for a dilation K is xy goes to kx, comma ky, which means you just take all the x's, multiply them by k, and all the y's and multiply them by k. Okay, so the question then is, how would we how would we do a dilation using matrix notation? Okay, well, matrix notation, I think you're going to find this is maybe the simplest thing you've ever done with a matrix. Alright, so if I give you these 3 points here, A, B, and C, I want to use matrix notation to do a dilation. All I simply do is put them into a matrix first. Okay. And let's say in this one, like in this example, we want K to be 2. Let's put these into a matrix. So this would be 3, 2. This would be 0, -1, that'd be point B, and 1, -3, okay? And then my scale factor is 2, and I'm going to do what's called scalar multiplication. I'm going to multiply this matrix, every number, by 2. So this is called scalar multiplication. I'm scaling the triangle up by a scale factor of 2, and that's going to give me, and the way that I do that is that I just multiply every number in the matrix by 2. So 2 times 3 is 6, 2 times 2 is 4, 2 times 0, that's still 0, 2 times -1 is going to be -2, 2 times 1 is 2, 2 times -3 is -6. And that's it for scalar multiplication of matrices. So you should try a couple out on your own here, and I'll give those to you here in 1 second. We'll do those. We'll do a couple scale factor problems, and then we'll call it good for section 9.7. So let me reset here and do another. We'll do this last part in another video.